Today I'm going to charge up the electric Brumby all the way to 100% and see how far we can go on a charge. The first thing I'll do is I will charge it up to 100%. So I've got my EVSE here set to 15 amps. And we'll plug in. So while we're charging up to 100%, there's a couple of things I need to check. One of them is the voltage that we're charging to, the voltage that the charger will turn off at, that I've set to 100%. Because I've recently calibrated the battery management system voltage, I just need to make sure that's all okay. I don't normally go to 100%, so I haven't been worrying about it, but now I want to do for this test, but I need to check that. The other thing is it's getting cool. It was 6 degrees this morning, and so I want to turn on the battery heaters. So the battery heaters at the moment are not on, and so it's saying 13 degrees because that's what the battery is. I'll set them up to 20 so that the battery comes up to that warm while I'm charging it. Battery heaters only go while I'm charging. It's sort of a preconditioning for driving. Good for a range test. I have 4 of these heaters, 4 of these controllers controlling the heaters. And so there's 2 in the back box here and there's 2 separate boxes in the front. I've always got to try and fiddle to figure it out, how to change them. There we go. It's set to 10 degrees at the moment. I'll set it up to 20. So to check this charger settings, I've plugged a laptop into the USB there. Then on the laptop, you can see I've got my charging table here. So this is saying that under test conditions, the highest voltage is 4.166 volts and 0% is 3.167. So these are not the highest voltages and lowest voltages, but they are the test conditions. That's what the state of charge they saw. I'm going to set my 100% to 4.1 volts. And my lowest voltage is going to be 3.1 volts when I'm driving the car. So under load, I want the alarm to go off when I get down to 3.1 volts. So this is what I need to set up today. I already have the 3.1 volts set up. I'm just going to check what my charger will turn off at. I need it to turn off at about 4.1 volts, maybe a little bit higher so that it settles down to 4.1 volts. Here's my terminal program here. Open the port and I can see what's going on. So we're currently charging. Voltage is about 173.0 at the moment, according to the charger. Let's go check what the BMS says now, because these used to be quite different. So 173.0. There you go, 171.2. So yes, they're still quite different. You'd expect it to be a bit different under charge. So there's 15 amps being drawn at the moment, so it should be higher while charging, and you'd expect that to settle down a bit when the current draw starts to go down, but we'll see how we go. Okay, so I want it to stop and settle with the cell voltages at 4.1 volts. So 43 cells, and I want a finish voltage of 4.1 volts. So my finish total voltage needs to be 176.3. So that's what I want to set the charger to. I probably want to set it a little bit higher than that so that it settles back to 4.1 volts per cell once it's sitting for a bit. So let's go back to the charger and see what it's set to now. Here it is. I'll just turn the trace off so that we can see what's going on. And then what have we got? Show config. And at the moment I'm in profile 4, 176.3 is indeed the voltage. That's what I wanted. Okay, so let's just put that up a little bit higher. I might go 176.5 and see what it's like. I've got a bit of wiggle room there. It doesn't really matter if I go up a bit higher. Okay, so what do I need to do? I need to change to 4, set profile 4. And then set max V. $176.5. 0.5. The other thing I'd like to charge is the termination current. So what that is when I am charging, the charger will keep on going until it's less than 0.1 amp in this case. And when it's less than 0.1 amp, it'll stop the charging. That's been, that takes a long time at the top of the charging. And what it means is when I am charging out and about and I'm waiting for it to charge up, I don't know when it's full. So if I can have it turn off a lot earlier than that, then it'll charge up pretty much full and then turn off, and then it'll be fine. So let's change the termination current to 1 amp. So here we are, the charging has stopped. The EVSE says that we have put in 6.6 kilowatt hours. If I look at the laptop, what I've done is you can see that it's down to 2.7 amps. Remember I set it to turn off at 1 amp. This was getting ridiculous how long it was taking, and so I eventually changed it to 3 amps. So if it went to 3 amps, I can tell from the time here, 3 amps would have been around here. This is 1324, and you can see by looking at the amps column, if I go back up to where it was 16 amps, that's where it was full speed ahead at 16 amps there. Last time it was at 16 was 1206. So with 3 amps, that's an hour and a half after it starts to reduce, which is still quite a long time, but I'll leave it at that. It's not as ridiculous as it was. We'll see how that goes. And so the voltage, it was putting up to 176.9. That seems to be what it's decided. Well, if I go to 176.9, then it should settle back down to 176.5, which is what I set it to. If we look, at the BMS reading of the voltage, at the time it was saying 176.3, which is what I want it to say. A few minutes later now it's settled down to 176.1, and the highest one is 4.10. I think that's good enough. I think it's going to be my 100% from now on. We'll see how that goes. Let's go for a drive. I'm ready to go for the drive. So what I'll do is I will reset this trip meter to 0. You can see the fuel gauge there is up high. I've reset that to be the highest that it can be, so that should say full now that I'm full. And so what I'll do is I'll drive, and every 10 kilometers I'll stop and take a photo of the speedo and the BMS, so the voltage out of the BMS. So the idea here is that I will drive along fairly flat roads at a reasonable speed, sort of 80, 100 kilometers an hour, something like that. And every 10 kilometers I will stop and check the voltage readout and take a photo of the voltage readout against the speedo. And so then I can do a table of how far I can go depending on whatever the voltage is. So then in the future, if I know the voltage is a certain amount, I'll look up that voltage and I should be able to see how far I can go before I run out. So I'll stop here for my first 10 kilometers. Trying to pick a road where there isn't too much traffic is interesting. Hopefully this one's okay. Photo of the speedo. So for this test, I want it to be reasonably consistent, so I don't want to be going up hills for one 10 kilometres and down hills for the next 10 kilometres. So I've chosen roads that are fairly flat, but then I didn't want to go on the highway because then I'd be stopping every 10 kilometres and holding up traffic. So I've sort of gone back roads, but reasonably straight and flat back roads as far as I can. I'll go into a town as well, trying to avoid towns because again that's slower and not quite representative. So getting close to the end surely. It's on 129 kilometres now. I'm sort of expecting 140, 150, something like that based on previous range tests. So let's take a photo here. So what I'm looking for as I get to the bottom of my battery is the voltage of the lowest cell voltage. And so I've set it to alarm me at 3.1 volts, isn't it? Under load. So as I'm driving, it'll come down lower than when I'm stopping and looking at it. So when I stopped and looked at it there, it was 3.45, I think was the lowest one. So I've got a little way to go. Oh, there we go. So I must be getting close and I've just seen the flashing lights. So I'll just stop here and take a photo. Of course, this is the furthest from home in my little trips I'm doing at the moment. So it alarmed under load, and then once it'd been sitting for a few seconds, it was reading 3.15. So I'll just go along slowly so I don't draw too much current. I've reset the alarm. The alarm's not going off now, so under this slight load it's not alarming, it's not under 3.1. There, that's just alarmed again, so we're under 3.1. The absolute low limit on the cells according to the datasheet is 2.0 volts. So hopefully my 3.1 is well above that and I can get the 2 kilometres or so that I need to get home. I'm just going along 60 kilometres an hour at the moment. We're home, I made it. The last little bit of a range test is always a bit anxiety inducing. Okay, let's have a look. Here we are under the bonnet with the BMS, so you can see here that we have highest cell voltage of 3.27, lowest of 3.03. F8 is fault 8, lowest cell number is 42, so that voltage is from that cell, and the highest cell is 15. It was 2 there for a second. Total voltage 136.6, that's my lowest I should ever get to. If you have a look at the fault codes, these are in order. So there was 0, then there was fault 3 for cell 42, so that's a low cell voltage. Then I reset it, it went back to 0. And then it came up again. So again, fault 3 for cell 42, and then we have fault 8 for cell 42. 8 is very low voltage, panicky low voltage. Here we are the next morning. I've charged the car overnight. I've charged up to 100%, same as yesterday. And so if we have a look at the BMS, it's been off for a little while, so it's settled down a little bit lower than what I was intending, but it's pretty good. I'll probably leave it at that. I maybe increase the charger just by a couple of fractions of a volt. And then I've had the laptop connected overnight. So here's where I first turned on the laptop here and got it connected, looked at all my voltages here, so set to 176.5 volts. We'll cut off it when it's only 3 amps. And it started out here, and it started charging. Amps are going up to around 16, 17. It kept on going all night until this morning at 7 o'clock or so. I've got a timer on the wall, and it turned off. So it turned off the power to the EVSE. So it was going at about 4 amps at that stage, so it was pretty close to being complete. Then it turned off. Here we go, 6:53. It's turned off the supply voltage, and that's come to a halt. And then I've come out and turned it on at 7:03 because I knew this was going to happen. Had a look at it, saw where it was at, and decided, yes, I'll set that going again. It's come back up to 3 amps, to 4 amps or so, and then it's finally got to 3 amps, 12 minutes after that. So it's taken about 13 and a half hours, up to 14 hours to charge up all the way. So what I'm going to do is to take some data out of this table and go and process all my photos from yesterday and work out a table for that as well. So I have a discharging table and a charging table, and we'll see how they compare to each other. Here's my table data here. Distance, total pack voltage, and lowest cell voltage. To get those, I had a look at the photos. So these are the photos I took as I was going on the drive. There we go, 30 kilometers on that trip meter there. And at that time it was 166.7 volts, the total pack voltage, and 3.87 volts is the lowest cell voltage. 40 kilometers, 50 kilometers, and so on. Produced this nice little table here. Now I've done a graph as well. If you come along here, you can see down the bottom is kilometers, and up the left is total pack voltage. So this is a pretty typical discharge graph for one of these cells. You come down fairly linearly, have a bit of a shelf, and then right at the end the voltage drops quite quickly. I did a charge graph as well, and again charging up quickly up to this voltage here, and then you've got your bit of a shelf here, and then a quite nice linear graph up the top. The main reason I was doing this was, one, to find how far I could go on a charge, and so at this voltage at 176 volts I was able to go 143 kilometers, but also I really want to produce this table. This table I can go for a drive and then look at the voltage on the BMS when I get to my destination, and so say it's 143, no, that's too low, say it's 163 volts, then you'd look at the table here, and well, I can go about probably 95 kilometers with the voltage set at that, so I can give an idea of where I can go from there. Well, that worked quite well. I now know I can go about 140 kilometers on a charge on the Brumby, and I've produced this little table here. I'll put that in the car, and so for instance at the moment it's reading 171 volts on the readout. I can look up on the table and go, I can go about 125 kilometers on that voltage there. So that should be handy. Would be nice if the readout, was inside the car, then I'd be able to tell without having to get out and look under the bonnet. I put the BMS readout under the bonnet because I thought it'd be too distracting in the car, and I think that's probably still the case. But it might be good for a future project to put a separate display inside the car and have it actually interpret this table. So instead of reading volts, to read kilometers of range left. That's a job for a future project. In the meantime, thank you for watching.